This is homework set number 1 for ECE 320. This homework set is a review of Circuits 1. It's what you can expect to see on the quiz on Thursday. The first problem is DC analysis of a circuit. Capacitors have no impact at AC. The current, I equals C dV dt. The current is the derivative of the voltage. At DC, the derivative is 0, meaning current is 0. If there's no current, ignore the capacitors. So in this one, you need to add resistors in series and parallel. So 200 in series with 50 is 250. In parallel with 150 is 93. In series with 40 is 133. In parallel with 100 is 57. In series with 30 is 87. So this is 87 ohms. On the quiz, I definitely recommend getting an HP calculator, or a calculator that does complex numbers. The app, 342, works really, really well. So for this one, if we want to add 250 in series, I would take 200, the first number you push on the stack. From then on, I don't need to use the enter button. So 200 plus 50 is 250. In parallel with parallel with 150. In parallel, resistors add as the inverse. So 1 over that, 150 inverse plus inverse. That's 93 ohms. In series with 40 is 133. In parallel with 100, take that inverse, 100 inverse. I'm at 57 ohms plus 30. Answer is 87.2 ohms. On problem 2 is AC analysis. So again, kind of show you how this one works. If all the x's are minus J100, I would have 200 in parallel with minus J100. So 200, 0, enter 100, negative, there's minus J100. Take its inverse, add the inverses. That answer is 40 minus J80. Plus 50 is 90 minus J80. In parallel with 150, in parallel with minus J100, is 31 minus J38. In series with 40, in parallel with 100, in parallel with minus J100, you see 30 minus J23 plus 30 is 60 minus J23. So definitely recommend getting used to HP calculators. They make a big difference on quizzes. So that's problem 2, 60 minus J23 ohms. Problem 3 is the mystery problem. Okay, problem 3 is a voltage nodes problem. I want to write the node equations for this circuit. Get on the quiz, I might ask you to write the node equations, put it in state space or in matrix form, then stop. I don't assume you have MATLAB on the quizzes. So here I've got 3 nodes. I need 3 equations for 3 unknowns. Start with the easy equation. The voltage source just says that V1 minus V3 is 20. Now write a node equation. At V1, I can't write the node equation because I don't know the current through the 20 volt source. Node 2 works. So the current sum from the node will be minus 20 milliamps plus V2 over 250 plus V2 minus V3 over 100 equals 0. And notice all the V2s are positive, everyone else is negative. V3, I can't write the equation because I don't know the current through the 20 volt source. So this is where you do a supernode. Draw a closed path. Any closed path works as long as I don't make the closed path V2. Just repeat the same equation. So this is one option. But I wanted to have resistors or current sources attached everywhere, so I know the current from it. The current from the supernode has to be 0. So that's this current, V1 over 150, plus V2 over 250, plus V3 over 350, plus V3 over 200 equals 0. 3 equations, 3 unknowns. If you group terms, put in matrix form, then solve, I should get 12 volts, minus 4.28 volts, and minus 8 volts. In Circuit Lab, if you build a circuit, find the voltages V1, V2, V3, I'll get the same answer. That's problem 3. Problem 4, current loops. Current loops just says the current around any closed path has to be 0. I've got 4 loops. I need to write 4 equations for 4 unknowns. Start with the easy one. This current source says that I2 minus I1 is 20 milliamps. Now I can't do loop I1 because I don't know the voltage across the current source. Can't do loop I2. Again, the current source causes problems. I can do loop I3. Around loop I3, I've got 250 I3 minus I2 plus 100 I3 minus I1 plus 350 I3 minus I4 equals 0. I'm back where I started. Loop I4 works. 350 I4 minus I3 plus 200 I4, and the back where I started equals 0. I need one more equation. That's a super loop. Super loop, essentially what happens is if you look at the first three equations, the 150 ohm resistor hasn't appeared anywhere, the 20 volt source hasn't appeared anywhere. I need one more equation that includes these two. So one possibility is this big outer loop. Another possibility would be the loop through here. I could also go 150, 20 volts, 100 ohms, 250 ohms, any closed path that covers these two. I chose the big outer loop, which gives you 150 I2 plus 20 plus 200 I4, and then back where I started, equals 0. To solve, group terms, put in matrix form. Again, on the quiz, this is where you stop. On the homework, I can solve. So throw this into MATLAB. I should get minus 100 milliamps, minus 80 milliamps, minus 62 milliamps, minus 40 milliamps. In Circuit Lab, if I double-click on the resistor right here, I'll get I2. Double-click on the voltage source, it'll give me the current in the voltage source. Double-click over here, I'll get I5. I2 I can't get directly, but I can get I2 minus I1, measuring the current through R4, or I2 minus I3, measuring this current. Essentially, I1, I2, I4 match up. This is the difference between two currents. Three of them match up, probably matches up. Problem 5 was not required on this one. If you did want to do number 5, to find the Thevenin equivalent, find the open circuit voltage, and then turn off the sources. If this is 0, meaning open, this is 0, measure the resistance. That gives you R Thevenin. For R Thevenin, I've got 150 ohms to ground in parallel with 350 to ground, in parallel with 350 to ground, gives you 80 ohms. For V Thevenin, find the open circuit voltage. That's write your node equation, solve, and I get V Thevenin is 11.23 volts, so there's your Thevenin equivalent. Again, that won't be on the quiz. That wasn't graded on the homework. We will be doing Thevenins this semester, though. Problem 6 uses superposition. This is a linear circuit, meaning I can treat that as two separate problems. Apply that as a 10 volt source, or a second problem, a sine wave, solve them separately. Starting with the DC source, in red, the input is 10 volts, inductor is j omega L 0, this is infinity, so I just have a voltage divider. The output will just be 100 over 100 plus 15 times 10, 8.696 volts. That's DC. Now for AC. AC, the input is 0 minus J3, real is cosine, minus J is sine. Inductor goes to j omega L, capacitor goes to 1 over j omega C. So now I've got these two in parallel, gives you 94 minus J23 ohms. I now have a voltage divider. It's R1 over R1 plus R2 times the input, gives you a complex number. Put the two together, and I have a DC offset plus a sine wave. Simulate this in Circuit Lab, that's what you'll see. V2 has a DC offset with a little bit of ripple, and that's the ripple part. So that's homework set number 1 for ECE 320.